Good afternoon, this is Tony Peters. It's about the afternoon of the 25th of April. It's been a long time since my last update, but I wanted to fill you in on exactly what's been going on. So I've been kind of attacking my project from a couple different angles. Right now, what I've got set up here is I'll just go right into explaining this. So I'm working on my photocurrent measurement system, and there's a couple different trains of thought on this. I was working on two different projects. One was the PCMS that I was planning on using to get an idea of what kind of energy is coming out of here, and that I can track it under specific conditions. And then for the intents and purposes of my black box simulator was during varying beta angles and intensity and wavelengths of light. I've been able to successfully maneuver through a few problems that I had. Everything, as per my last demonstration, seemed to work. And then I got some interesting data from the UV and IR perspective, and I'll kind of touch base on that in another video, but I really wanted to kind of focus on my two different PCMSs that I was working on. This one is more of a portable design. It doesn't look very portable right now, but it's intended to be that way, because I'm trying to take all of these really big bricks here and try to condense the design so I can build a PCB with something a little bit like this. I'm already starting to put it together and put everything in the back here, so I can put all of this neatly inside one of these little black enclosure boxes. And what I intend to do with that is use it for a battery monitoring for during the initial condition cycle for some of those really expensive batteries that you have. And maybe not something like these, but something like much bigger batteries that are like $200, $300, so you can make sure that you're going through the proper charge profile all the way down to trickle charge when the battery's fully charged. So this is something that I was working on. I've kind of changed it up a little bit with everything from the displays. I'm trying to get a little bit, I guess you could say, fancier here. Typically I use something like this with the LCD shield. I found that a nice big display on a piece of test equipment is really good, but not exactly good for something portable that you want to take to a lab or something like that, or out into the field and say, hey man, I've got this problem with the battery, can you take a look at it for me? So I've got my own custom power meter and data logger, because I didn't want to have an entire computer set up with me too. So what happens is I have a micro SD, let me tilt this a little bit so you can see it. I have it pinned upright. A lot going on here on this breadboard, but I have a micro SD card that I could just throw in there, and it holds a lot of data. I think this is a 64 gigabyte card, but I've got these little OLEDs now, and I'll demonstrate over here kind of what I'm planning on doing with the PCMS. So this one's a little bit, I would say, more robust than this. This is just for monitoring batteries. And this here is my TMP007 sensor, which it's got this little resistor here to hook up to change the I2C address so that the coding works a little bit better. But what this is planning on doing is I'm going to take this design, I've been able to measure the photocurrent, so I'm getting my volts, I'm getting my amps, I'm getting my related power, but I'm also saying, all right, so something I want to incorporate into this is the temperature, because a lot of these batteries, you don't want to exceed 65 C. Well, a lot of the battery sensors and power meters don't have that capability. So I have this contactless IR method that I put together with my artificial sun module system on my solar test array, basically the star at the top of the thing that goes all the way around, all over your solar cell. It'll give you the surface temperature, so I'm going to incorporate that. So going into here, this is obviously condensed, but I'm having some issues right now with Chinese-made FTDIs. I don't know what it is. I can plug this in, no problem, but then after a second or two, it just stops working, and that seems to be a really common problem. So what I'm going to do is probably just go back to the interface that I can use with a micro USB, either by one of these, and I don't lose that much portability there from that respect. But I can fire this up, and it uses a battery interface with a TP4056. Seems to work pretty well so far. But this is the bread and butter for what I really want to show, so I'll just kind of zoom in over here. And also I've been able to kind of finagle together my super sweet and sophisticated enclosure here is my, basically my calibration system. So I've got a lot of different things here, but it's basically going to go through what's your UV intensity, what's your IR intensity. So I've got a couple different things here to kind of calibrate it and pretend that this is the cell, get some baseline data to make sure everything's all right, good to go for baseline, and then we can run our tests. That's something that's still working on the coding, but I've already kind of put that whole thing together. So if I fire this up, this is going to run off of the full SD card, so I could just throw that right back in there. So you could see here that it's already, let me maneuver some of this away. There you go. A little bit easier to see here. I'll zoom in a little bit on this circuit. So right now there's nothing hooked up to it. So it's going to show that 1 volt just kind of there within the noise. So once I actually hook up the solar cell to it, and I've got a couple different designs. Of course, I got my 1 watt panel, but right now, each one of these red dots, it's logging right now. And I had a lot of issues with the code that I was running before with comma separated values in Excel, and that just wasn't, it just wasn't compiling the data properly. So what I did was I made them all text files. So you're gonna get a separate text file for your current, your temperature if you choose to use it right over there, and your voltage and your time. So you got all 3 of those in different kind of time constraints, and you want to make sure that the power curve kind of follows the voltage curve in this instance, because the current should really be pretty constant. But it's all going to change based off of those varying beta angles. So I ran a couple different tests just to get an idea. Let me zoom back out and then I'll kind of show you what I have on my computer. So basically what you do is just power that down and then you can put the data in. So I've got something looks a little bit like this. Basically I just put it all, copied and pasted in Excel. Sorry, let me move this back around. So this is just my 1 watt panel right now, and just kind of follows that curve. This is what it typically would look like if you're, cutting it off from a Eclipse profile, and then you just put it back in the sun, and you slowly introduce it back in. But these are pretty sharp curves, so it's basically like me moving my hand on and off the solar cell. So that's something that I have right now, and I'm getting results like that, but I want to make sure I'm getting good current data from that too. And it doesn't look like I'm getting all of it just right, and I think it has something to do with the way that I've hooked up my load to it. So I'm going to keep experimenting with that. I've got, like I said, I've got my 1 watt solar panel that I've got right here, and I've kind of maneuvered the interfaces here so that I can plug it directly in to either one of my setups. This is something now that I've wired up together. These are some flexible silicon-based solar arrays. What I did was they're carefully measured, as you can tell, from not protruding over the median or the very thickest part of the airfoil, going over to the leading edge of the airfoil, because you don't want the solar cells on the leading edge anyway. So you want them coming off the trailing edge right back here. So air flows nice and over around it. This obviously doesn't have any cover glass on it or anything like that. But what I'm gonna do is, right now these aren't wired in a specific fashion, but I'm gonna try them wiring them in a series in a parallel configuration, see kind of what data I get there, function of temperature, and I can throw this right into my black box simulator, and it could just kind of go all over and give me some kind of profile or spectral response characteristic for this scaled Triton UAS wing, which I think will be pretty interesting to see that data, and then I can keep turning it and see what kind of data I get from there. So like I said, I'll probably have another video later on to kind of describe my updates on the BAPSIS and the rest of that. But the future, I'm going to start using, instead of just calibrated light emitting diodes and all these other things, I'm going to start using lasers. So just because I started getting some interesting data with my laser, just my calibration laser, which is like 625 nanometers. but here I've got red, green, and blue. They all look a little bit different because they were all different levels of fabrication to make and test and calibrate. So pretty good output here. So they're a little bit stronger than my other ones. So because they're so much stronger, I actually need to build a different kind of enclosure. So that'll be coming down the pipe much later, but I figured it'd be good to have those so I can try at least going through some laser testing for RGB values under very focal points, and because the spot beam on them is very small, obviously smaller than the entire cell, but you're going to get some really good characteristics from there, because that's the commercial way of testing cells, is actually by using the simulated emission of radiation or light amplification, so lasers. And so that's a pretty common method. I figured it'd be kind of interesting to kind of verify what I'm getting, but that's where I'm at right now. I'm actually looking at the rest of my setup here to the left, which you can't see, but everything else seems to be going smoothly. I'm kind of running through some FTDI problems with syncing to this much smaller board right over here. And then I'm running into some wiring issues with how I'm wiring this as my simulated load to this ENGR599 sensor module. So more to come on that. I think that at least the voltage profile is very spot on, very little noise, and like I said, any questions, feel free to ask me, and thank you for your time.